Okay, this is the last section of chapter 7. I'm not sure what the speakers are doing, so I'm going to turn it up a little bit. And these are the steps here that you're going to go through. If you do it by hand, this will be what you calculate. Um, you'll use this value if you're doing it by hand. If not, you're going to use your calculator. I'll show you what steps. We're going to start the same. The only thing that you'll notice that there's no mention of a mean, and there's no mention of a standard deviation. That's how we know. There's some crazy wind blowing. That's how we know that this is going to be the no mean and the no standard deviation is how we know it's going to be a one proportion z-test. Is the no mention of mean and no standard deviation. So we're going to still go through and read. It says right here we have a claim that less than 45% of the United States adults. Okay, so I'm just going to go right quick. And the proportion that they're claiming, the proportion is less than 0.45. Yes, you'll always change this into a decimal, the percentage into a decimal. So this is the claim. You should always be able to get your claim directly from the reading. So if this is the claim, what's the opposite of the proportion being less than 0.45? That would be that the proportion is greater than or equal to 0.45. Okay, so you've included all possibilities that the proportion is less than 0.45, which is the claim, and then the opposite of that. Just like with the others, if it contains equality, it's the null hypothesis. And the statement without the equality is the alternative hypothesis. Um, now that we have that written down, you can draw your picture. I don't know if y'all can tell or not, but I'm trying to eat while I'm doing this. I'm starving. You think I could wait 5 minutes, but I can't. Okay. The alpha is 0.01. Oh, I forgot to figure out what kind of test it is. We look at the alternative. This is less than, so that means it's a left tail test. And we know it's a left tail test because this is less than. So it's a left tail test. So we draw our picture. And we shade this in. This is alpha, 0.01. And we need to find the z value. They call it z naught. Another thing that you need to know is this thing right here. I haven't been saying this on the last examples, but it's true for all of them. This is called the critical value. You'll need to know that because that terminology is used in the, I believe it's the in-class portion of the test. It gives you, information like this, and it asks you to find the critical value. So be sure you understand what you're looking for when you do when they ask you for the critical value. That's the z value that goes along with the given alpha. That's your critical value. So how do we do that? You've got one of two choices. You can go to your Z table, or you can use your calculator. I don't have my Z table up right now because I did not do a good job of setting everything up, but I do have my calculator. So I'm going to go to my calculator. Actually, yeah, I'll go to my calculator. And I need just a regular calculator page. This is menu 6. To find the Z value, it's a distribution question, and it's an inverse norm because I have the area. So I'm going to choose inverse norm. The area, what was the area? 0.01. And we're on the Z axis. So that's 0 and 1 staying there. Tab down to OK. And that gives me my Z value of negative 2.3. Usually do 2 decimal places, so I'm going to do negative 2.33. So my critical value is negative 2.33. Okay, so now it's time to do the test. And this is a 1 proportion Z test. So I need to look and see what my calculator wants from me, what information my calculator wants. So I'm going to go to menu, statistics, option 6. This is a statistics test, so I'm going to choose option 7, and it's a 1 proportion Z test. Oh, my dog is chewing his toy up. Okay, so this says it wants the p-value for my claim. That's what that's saying, the p-value for my claim. So the p-value for my claim, it wants the number of successes, and it wants the total number of trials, and it wants that. Okay, so let's see if I can put all this over here. It wants my p-value. Well, that's easy. My p-value is 0.45. And then it wants my x value. Okay, so to find my x value, I have to go to the sample. I have to go down here to the information about the sample. So I have my n. My sample is 100. I ask 100 people. And here, instead of giving me the x value, they don't give me, they give me p hat. They give me p hat, which is 0.41. So you have to remember from, I don't remember which chapter, the chapter before, I believe, but p hat was defined to be x divided by n, the number of samples. I mean, he is tearing that. Would you stop? So we know that p hat is 0.41, and we know that our sample size is 100. 0.41. So we need to find the value of x. Well, this is just a simple proportion problem. So how do we get the x by itself? This says x divided by 100. So we've got to undo the division by 100. So we multiply both sides by 100. Multiplication symbol. So those cancel out, leaving x by itself. And then we have 0.41 times 100. That comes out to be 41 is equal to x. So that means that in order for this, in this sample, in order for 41% of the people to say that about their passwords, then there had to have been 41 people out of the 100 to say that. Okay, and then of course the alternative hypothesis, all they want to know is what symbol is being used. So that's what we're going to put. So the proportion from the claim, the number of people that made this 41% out of the total number of people in the sample, and then that. So we just go put all that in on the calculator. So we have, let's see if I can make it smaller. So we have 0.45. We have 41 out of 100. And from our drop-down menu, we're going to pick less than, and we'll tab down to OK. This is our test statistic, negative 0.81, and this is our p-value. So I'm going to change colors real quick. Oh, there we go. I'm going to change colors, and I'm going to say that our z value from our test our z value is negative 0.80. I don't think that rounded, did it? Does not round up. And our p-value is 0.2107. Our p-value is 0.2107. Was that right? 0.2107. Okay. So this thing right here is called our test statistic. And it needs to be plotted up here. So remember, this is a z-value. This is where 0 is. So we're saying that's where negative 2.33 is. So not even over to 0.1. So my z-value, my test statistic, is going to be right there. That's negative 0.8. And that's just an estimate. But that's where my z-value is. It is not in the shaded section. So this over here is reject. This over here is fail to reject. And remember, the only thing we test is the null hypothesis. So we fail to reject H sub O. So since we failed to reject, now we need our cheat sheet, and I am pretty sure I do not have my cheat sheet up. So let me see if I can go find it real quick. Maybe it's on this one. Yeah, this is it. So here's my cheat sheet down here. I'll copy and paste it over there so that we can see it all at the same time. Okay, so here's how we use the cheat sheet. We go, all right, so the claim right here was my alternative hypothesis. So my claim is the alternative hypothesis. That's what that says. So I'm going to go here and I'm going to go down this column and I'm going to pick one of these. I failed to reject, and my claim is my alternative. So this is the sentence structure that I'm going to put. So my conclusion is going to be, I'll write it in blue. There is not, that's the first word that goes in my blank, enough evidence at 1%. This is my alpha. I'm getting that from right there. Significance level to support, there's the other word, the claim that, and I don't remember what the claim was, that less than 45%, less than 45% of U.S. adults use passwords that are less secure. There is not enough evidence at 1% significance level to support the claim that less than 40% of you. Okay, so the other test that we could do is to compare P to alpha. Remember, was it here? Here, there we go. The other test right here is this one. We compare P and alpha. So I'm going to compare P compared to alpha. And P is 0.2107, alpha is 0.01. And when you compare these two, you see that this number right here is greater than, so P is greater than alpha. And it says that if P is greater than alpha, we fail to reject. So we got the same results. We fail to reject. And so it doesn't matter whether we use the plotting of the test statistic against the critical value, or whether or not we compare the P area, the area for the test statistic, compared to the alpha, which is the area for the critical value. Doesn't matter which one you get, fail to reject both places, and both places, this would be the sentence that we would use. I'm going to stop this and create another video for the next one because I don't want my video files to get too big.